Hey guys, today we talked about matrices. Now matrices look somewhat like this, what you see on the screen right here. So what we have is a list of numbers with rows, which goes down the row just like this, and columns which goes to the side, just like this. Okay. Now, most of the matrices are represented by a letter, so I could call this matrices right here an A, on matrices A. And usually on the side, we have a number of rows and columns displayed. So, for example, once again, this particular matrices right here, if I call this matrices A, I have 1, 2, and 3 rows, so it's going to be 3. My columns would be 1 and 2 columns, so I would write this A3, 2, or I can call this 3 by 2 matrix. So that's just the vocabulary and notation for our matrices. Now we're going to go for the operation. The first thing we're going to look at is addition and subtraction of matrices, and this is very simple. Right here, all I'm going to do is I'm just going to match up the places. So I have 1 on the very first row and very first column on this one. I'm going to match it up with the number that's in the same place. So I'm going to do 1 plus 5, which gives me 6. Same thing, -7 plus, on the same place on the top row in the middle, -7 plus -2, which gives you -9. Once again, the same thing, 11 right here. Last one on the first row, last one on the first row, add them together, so we're going to get 17. Same thing, we're going to have first one on the second row. Now we're done with these on the top rows. We're going to move into the second one. First one on the bottom row, first on the bottom row, added together, so we're going to get 13. 3 plus -1, so we're going to get 2. Now we're going to get -10 plus 7, we're going to get -3. And that would be our final answer right there, the one that we just found. So this is more of a numerical type of thing. You can kind of reason it through and it makes sense to you. So this isn't too bad. And same thing goes to the scalar multiplication. Right now, it looks a little bit weird just because we haven't been exposed to it yet, but this is the same thing. I kind of think of these little brackets as parentheses because it kind of helps me too. In that way, I know that this is saying 3 times the whole thing. Now remember how I kept saying math is fair? So we have to be fair. If I'm multiplying this whole thing by 3, I'm going to have to multiply every little thing by 3. So I'm going to have to do 1 times 3, which gives 3, 5 times 3, 7 times 3. I'm going to go on and on and on. And that would be it. Not too bad. Once again, scalar multiplication is also something that's going to make sense to you. Now, the matrices multiplication, where we have to multiply matrix by another matrix, is a little bit, it's a bit more weird. It's not difficult per se, but it's just weird. So let's see what it gives us. Now what I'm going to do is I'm going to multiply the top row by the column on the next one. So I'm doing the top row first, the first one first, and then I'm going to go by the column, okay? So let's see what we can do. On this one, we're just going to once again follow the rules of matching it up. So you're going to go 2, the first spot on the first spot, 2 times 1. And then I'm going to add that and then go 5 times 2. add it. So I'm going to get 6 times 3. So that would be my first row. First row, first column, we've already made it. Now the second one that we're about to do is basically same thing. I'm still going to use this the first row. I'm going to go ahead and use up all of the columns right here. So the second one would be same thing, 2 times negative 5. I'll mess with the first places, add it. 5 times negative 6. And I'm going to have 6 times negative 1. That's good enough because I don't have a place to write that down. So you see how I went from the one row and then I did the column. Then once again the same row and the last column. If there was another column right there, I'll do the same row and then the other column too. Now let's move on to the second one. So we have this one right here. Same thing. Second row, first column, so negative 1 times 1 plus negative 3 times 2 plus 2 times 3. Now the same thing happens. This one times that one right here. So we're going to have negative 1 times negative 5 plus negative 3 times negative 6. And that plus, lastly, we're going to have 2 times negative 1. Okay, I'm going to close the bracket. I know, it's messy. But at this point, we're almost there. All we have to do is now we have to just solve all of these things that we've drawn out. We're just going to solve these things out. And the answers that give us will be our final answer. So quickly, you can just go ahead and plug everything into your calculator or however you want to do it. I'm just going to do the first couple together with you just to show you what it looks like. So we're going to have, there we go, 30 on the first one. And we're going to have negative 1 here. Correct me if I'm wrong. I'm messing up the smallest things today. So feel free to tell me if these are wrong. Then I'll just go back and fix it. Here you go. And that's 3, by the way. So we get, there we go. So 46. Okay. All I did was I just plugged into calculator. Hopefully I plugged it in right. And that would be my final answer. So we've learned about all the multiplication, scalar multiplication, everything else about the matrices, and it really wasn't too bad. Please let me know if you have any questions. If I made some calculation errors right here, forgive me. I really don't want to go back and check it. So if you want to, you can. And if you have any other questions, please let me know.